videos, how the discussion session is operated. But it's open to you. And then also see the classroom is divided into 3 parts every time. So second part we will have a save the time to find out makeup class hour and also the introduction of yourselves. Because next week, next Wednesday, 14th of March, we will have a project team up. So you should know each other to make a team. Okay? The rule for team up is heterogeneous. Heterogeneous means you should be different background. Different background, as much as possible. So heterogeneity is a constraint for the teaming up. So your friend will not be your team, right? For example, right? So you should know each other to make such a team. And also, I hope we can have 3 members per team. Then one is missing, right? 23 person. Then it's hard to find the. But anyway, we will find out. Say one team can be a two member team. Right? All right, so it can be a self-introduction of student of everybody today, right? And 23 persons, so it takes 23 minutes. 1 minute per person, right? 1 minute. So you should use English for your self-introduction. All right, so that is our second class session today. And makeup class probably looks like where is it? Makeup class. Right, this one. I don't have time to. So this one is coming from 1 year ago, right? We should find out such a slot to make. So I guess your class hours are already fixed, each of you. So you can find out available time slot among 23 persons. It's not easy. Last year, the total member was 16 something, the student number. Now we have more students, so it can be harder to find. But anyway, we need such a one because first replacement will come 21, 21, 21. 21, I will have another meeting there so that I make such a question mark there, depending on the available time of yours. All right, did you get my presentation slide today because it was late? TA sent 2 hours ago. Yes. No. Okay. But you get email from TA, right? Everybody. Do you have any problem still? Problem getting email from TA? No. So your email is already arrived. About KakaoTalk, did you get KakaoTalk message from TA and myself? No? No? What happened? Oh no, KakaoTalk is another class. Sorry, sorry. That is my another work I should do. Kakao. International student. Do you have a Kakao ID? ID? Yes. You can do, right? So we will make a Kakao group of this classroom. Sorry, I mixed with another classroom. So email and Kakao can be used as a SNS At least for next Monday, actually. Homework one is already sent out, right? Yes, you got the homework? No? No? Oh, maybe you are missed from the list. But it is on the website already. Right? Website. You can visit. Also, you can check the emails. Right? All right. Any question? Question? Then we can go on to the slide. Sun offshore structure. Right. This one is already sent to you, right? Through email, but it was late, 2 hours ago. I guess the file is on the website already. Is it right? Okay. Not yet? Not yet. Only email. Okay. So this is the book we are trying to cover for the ocean engineering. And this is the chapter names of the book. We will cover some of the chapters, not all of them. So now I'm trying to cover chapter 3. Chapter 1 is covered in last week. Right. So offshore is far away, right? Onshore, offshore, right? Far away. So it should be deep water there. Deep water. Oil and gas. So onshore is shallow. So onshore gas oil is exhausted already. Not all of them. Now the shale gas is coming. Right? Shale gas is coming. It's a new technology brought a new oil and gas, so that makes more oil production. But anyway, traditional oil and gas is becoming exhausted. And larger, bigger offshore reservoirs than onshore. So it is about, because every time they found a new reservoir, so there is no exact number yet. Every time it is increasing. 20 times, 88 times. But it is expensive. Expensive in terms of 20 times expensive to catch oil and gas, because it's a deep water, drilling several kilometers down. It says, depending on the situation, but many big shipyard people saying that the oil price. Do you know what is the oil price now? Around? Yes. Right. Around $50. But it was 100 4 years ago. At the time, it was very nice for shipbuilders. Very nice. Not for me. I should pay more for the gasoline. So they are saying if oil price goes up more than $60, it will be good for shipbuilding company, because there will be more orders for offshore plants. And survey, exploration, technology gives you less money for developing, but also there's competition coming from shale gas because of the technology. This is a little bit outdated 1 year ago, right? 1 year ago. Crude oil price, $50, right? At the time, 1 year ago, still around this figure. There are so many different oil indexes. You can see many country names there. This is one for whole April time. So several days. So it's still fluctuating between 53 and 48. Fluctuating. Similar to stock market. oil deposit in the world, no oil in Korea and Japan. Uh, uh, Pakistan, yes? Yes or no? Oil or gas? There is gas, not much oil. No Turkey. Where is your country? France. No, I cannot see. Where is it? Where is it? Where is it? It's strange. Oh, is it Mediterranean Sea something? Right? This one looks like a Mediterranean Sea. Eh? There's some. Okay. All right. Offshore field development. All right. There are so many wells, small wells. This is each one is a drilling pit. A pipe is here. So they are collecting oil or gas. Sometimes far away. So this is under the sea. They are saying subsea technology. And riser, pipeline, field line, and there is a processing structure. This is we call offshore structure. Offshore structure. The size is 100 meters each, say 200, 300 meter lengths. This one. Width and so this is big one, right? Still big one. Say 100 meter means 20 or 30 floors, right? So this is big, but field is much bigger. Fixed and floating structure. This is floating structure. This looks like a floating structure. Drilling devices and surface platform surface. This is ocean surface platform, and drill pipe is going into this pipe. And blowout preventer. Blowout preventer is 2 places now. This is bottom of the offshore structure. The offshore structure. The plant is a floating or something like that. And then this is seabed. Seabed means water and land interface. Soil, water interface. Seabed. There is another blowout preventer. Can you remember several years ago there has been a big fire explosion in Gulf of Mexico? Right? The BP, British Petroleum, it was the owner of that plant. There has been a big explosion of this kind of structure, and the fire goes on probably months. I don't have exact. And due to that accident, BP lose big money, billions of dollars. So, in that case, that was the problem of this one, blowout prevent. So there are many cases, but one simple case is when this is a drilling bit, the front. When it touched the reservoir, say this one can be a gas reservoir. When you touch this one, the pressure there is very high, right? So it can be rising fast. It can be a blowout. Or temperature can be higher because of the speed, something. Then it can ignite. Right? We don't know yet, but somehow, so there is a chance. There is a high level of chance. So that kind of situation, it should be working. This one is cutting off somehow, shrinking down, right? To stop the blow. That is the work of this device, but that was failed at the time. that I heard is reasonable. You can find more information from the YouTube or Google. And drilling fluid is somewhere mud to drill and return to tank. So they need lubrication. Water and fluid and mud is used as a lubrication for drilling. And casing and riser is line pipe. Drill bit. Okay. Offshore drilling. Oh, there's a video. Default. Let's see. Right. Sound.
Offshore drilling rigs have all the functions of onshore rigs, but also need to stay on station in a variety of sea states and allow for secure connections between the surface and the sea floor. To start an offshore well, a quick line large diameter collar 2 on the conductor is embedded in the sea floor. It is able to hit the jet to over 7 meters high pressure sea level. When the conductor is penetrated about 250 feet, the jet curve is retrieved and a drill bit introduced. The cuttings are just washed to the top of the well by seawater pumped through the bit. A second run of conductor is now lowered into the hole. At the bottom of the conductor is a guide sheet that stops the conductor snagging on the well bit. Above the sheet is a flap valve called a pivot collar. A cementing tube is connected to the top of the conductor. A plug that pushes the seawater out is driven downward by high-pressure cement that fills the conductor. On reaching the third collar, this plug is ruptured. The cement flows out of the bottom of the conductor and up the annular space between the well bit and the conductor. The cement flow through is removed, and when the cement is set, drilling continues with a smaller diameter drill, penetrating cement plugs into a collar and into fresh rock. After a suitable depth has been drilled, the drill string is removed. Then steel tubing, known as casing, is lowered into the hole and cemented in place. This first casing line has an attached blowout. A blowout preventer, BOP, a robust set of valves that can shut in the well even if the drill string is down the hole, is then lowered and walked onto the wellhead. The BOP is connected to the subsurface by a large diameter tubing known as a riser, which allows drilling fluids to be returned to the surface. From this point onwards, the drilling procedures are similar to those used to drill an onshore well. With the riser in place, seawater is replaced by a special fluid known as drilling water that is pumped down the string and exits through ports in the bit. The mud not only cools the bit, but also clears the cuttings from the hole. The cuttings are captured at surface and examined by geologists to characterize rock types or green content. As drilling continues, sets of decreasing diameter bits and casing rods are used as the well penetrates deeper into the rock. Each run of casing is cemented in place to provide integrity, a sealed system from top to bottom. The density of the mud is controlled by the mud engineer, adding dense minerals when needed. The aim is to produce a column of dense mud which exerts sufficient pressure in the well to counteract pressure from fluids encountered in the water. This combination of the dense mud column contained in properly symmetric casing aims to control pressures in the well. The BOP provides a further level of security. When the well penetrates the reservoir rock,
You can stop over there. Right. So that is, you can watch from more. And then there is a two structure types. One is for drilling. The other one is for production. Drilling is for exploration. Test whether to find out the reservoir. And then when it is succeed, you find out big enough reservoir, then it goes up. Then the other device is coming for only for production. Right? We call this is a production platform. The other one is drilling. Say drill ship is very famous for, especially Samsung heavy industry of Korea. But any other ship companies are making this drill ship or submersible or other types. And for the production, there are different types, say TLP, FPSO. I explained this one. So here it is. So fixed platform, FPSO, semi-submersible, SPA type, TLP type, and long tower. There are also some pipelines direct to the land or the other method. Offshore platforms in 10 years ago, numbers. So fixed platform is most, right? But you see that FPSO is increasing numbers. Also, you see that the size of that FPSO is much bigger than fixed platform. This fixed platform is convenient and shallow water, so it can be many, many. But FPSO should be bigger for the economical reasons, much bigger. So not only the numbers, you should see the whole size. Other things, TLP, SPA type, or other things. And the water depths, you see that is a feet, but you can see that 8,000 feet can be 2 to 3,000 meter. Right? Jacob rig, you see the types. Jacob means there is something like an elevator tower, so that the platform itself is going up by itself, going up by one. It's similar to tower crane over the construction site. Tower crane, they are lowering and down by itself by using Jacob gears. Legs up and shallow waters. Fixed platform, similar to Jacob, different. And anchored direct onto the seabed. Sometimes it's made of concrete. This one is made of concrete. This is steel structure. Depth is less than 500 because of the economy. Tension leg platform. Tension leg means there is a high tension wires or leg. We call it a leg, high tension. By using buoyancy, if you have a big buoyancy, then the body is trying to float, right? But using tensioning down to the bottom, it is fixing. So the tension leg means the leg or wire has a high level of tension because of the footing and also buoyancy. Buoyancy comes from the air inside this box. So that because of the tension, it does not move or small movement. That is the idea. But you need to have a high secure footing depth. You need a high secure installation depth. Semi-submersible is very interesting. I should say, can you read this one from there? SWAS or how can I talk? SWAS is a short name of semi small water plane area twin hull ship. Something like water plane area is uh, water bottle. Can I borrow your water bottle? This is ship. When I put this one into the water, there is a draft line, right? Probably around here, right? Draft line, similar to the water level here. Water plane area is the, if I cut the body using the water surface, there is an area of cutting plane. Right? We call this is area of water plane area. So this is a shape of the ship, a special shape. So this is a water surface, waves here, water surface. So if I cut this one, the area is very small. Small water plane area is the special to this ship. And twinner means bodies two bodies. Twinner ship. We will see this one more in the later stage of the class. And this has same idea, right? But why they have a smaller water plane area? Because if it is small, then they can get a less effect from the wave. The wave force is smaller because of the area is small. The same idea. They see, you can see from the color coding, you see that there is a draft line here. Right? So that area, water plane area is small there. To reduce wave forces. Wave creates motion of the body. So they want to have a stable platform, even though there is a wave, big wave. So we call it a semi-submersible. Submersible means submarine, right? Submarine. But semi-submarine. Half of the body is submarine. Platform is above. Between them, there is a small column. That's special. This is very similar, right? Right. So this one gives you the buoyancy forces to support the weight of the ship. Buoyancy coming from the displaced water, right? So buoyancy coming from this submerged body, submarine. You have a submarine, two submarines, yeah, because it is lengthwise in this way. The ship is lengthwise. I show you cut plate. Question? Right. So wave-induced loading, sensitive load changes, stability, but stability is problem. Stability because of the small water plane area. We'll see more in the later. And also dynamic position is important. FPSO, I already explained this one. Spot platform is a long tower but still floating. Similar to tension leg, but it has a more tower. So also it is a very deep water, very deep water. Design consideration, natural frequency of the wave, sea waves, of storm condition. And there is a natural frequency of the structure itself should be different. Otherwise, there can be a resonance between structure and wave frequency. So we can use the same idea of dynamics, vibration, resonance, vibration, resonance. Design wave concept, the worst case, the largest wave of 100 years time interval. There is a statistics. And otherwise, the structure failure or fatigue is another problem. 100 years return period design wave, biggest one. American Petroleum Institute provide this chart. Maximum wave height in meter, 22 meter, 27 meter. Gulf of Alaska, Gulf of Mexico, Southern California. Wave period, maximum average 100 1 hour wind wind speed. So how can we calculate wave forces? Because structural body will get the wave force. Have you been to beach, wave beach, artificial wave beach or natural wave beach? You have experienced how big is the force coming from the wave to your body? It's very big. Same as the water is thrown into your body, right? Water amount of the bottle, big bottle is thrown to you. Force is big. Important parameters for designing of forcing, diameter ratios. I will not cover this one. Wave load regimes and K is important. Morrison equation is also used for the calculating wave forces. And then subsea systems, same as this, but more names: manifold, umbilical, jumper, wellhead. Subsea, wellhead, or Christmas tree. Looks like a Christmas tree. And control system is also used there because we need to control the motion of the umbilical terminal, also the ROV is working on there. Connection, pipeline, Gulf of Mexico, Louisiana, Gulf of Mexico. There's many, but we cannot see because it's covered by ocean. But there are many pipelines. Flow lines and pipelines and risers, flow lines, pipelines, riser. Riser is coming from here, bottom to the offshore structure. We call this riser. Very long, kilometers long, right? Kilometer pipe. So it looks like very thin, even though there's a steel pipe of this diameter, but the very long and far away, it is very flexible. It's moving. It looks like very thin wire or silk. And also foundation onto the sea bottom, caisson pile and suction caisson. There are different devices. You see that the size of the footing, human is there, size is big. Okay. And then suction pile. Sometimes it is soft sand or mud, right? In Korea, the western Yellow Sea, the seabed is very soft, mud, tens of meters of mud. So suction type is, they go into the seabed and then securing the footing. That is one idea. All right, quickly finished. Question? No question? Then we go on to TA's discussion session.